Hello and welcome to my YouTube channel Web Learning episode where knowledge is shared. In this video you will learn how to start the STM32Cube project, how to open the project in an IDE, how the work project structure is built. So let's get started. If you're unfamiliar with the STM32Cube, you can open my previous video and you can find the link right in the corner or in the information below. In this example, I'll use the STM32L0 Nucleo board, where you can find also the link in the below description. So let's start. I'll click New Project. I'll choose Board Selector. I'll choose Nucleo 64 and I'll choose the L0. From the L0 we have two boards and I'll choose the L053. I'll click OK. As you can see, the project is already built. All the pins of the Nucleo board already set. At this time I will not do any changes. We have two buttons. We have two pins already set. One is LD2, the green LED, and the other one is the PC13, the blue push button. I'll click Project, Settings. I'll make sure to put in a new project name. I'll choose the environment that I want to open it with. At this time, I'll use the Keil MDK ARM v5. In a later video, I'll show how to use it for the M0 and M0+. I'll go to the code generator. I'll copy only the necessary library files and I'll set all three pins as analog. I'll click OK. And again, Project, Generate Code. At this stage, I'll do Open Project. And the system will start the Keil. As you can see, the cube opened few directories. The first one, or the Simsys driver for the STM32L0. The second folder has all the libraries that we set for the STM32 Nucleo. In this folder we have all the HAL drivers that are set for the STM32 Nucleo. In this folder, Application User, we can find the main. And in this folder we can see the startup file. Let's open the main. The way that the STM32Cube structure is as follows. In certain areas, you'll find that the cube opened comments where user code begin and user code end. You'll find it all over the main. The reason for this is that you, the user, can only add your code between those lines. The reason for this is that at any given time we can go back to the cube, we can change some peripherals and go back, and the cube will not affect any of the changes or anything of the code that we wrote between those lines. For example, I can go back to the cube and I'll add, for example, two pins for ADC. I'll click Project, Generate Code. At this point I'll do close because my project is already open. And when I change to Keil, you'll see that Keil already noticed that something else changed my main.c. And it's asking me if I want to reload them. If I click yes, you can see that the new line was added. This line was added by the STM32Cube. And again, if I wrote any code between those lines, the cube won't affect them and won't change them. The structure of the user code that you can add are user code begin include, user code end include. user code begin private variables PV, the user code and PV. In this area, the STM32Cube adds all the system clock configuration, the GPIO init and configuration, and the max ADC init. Those settings can be found at the bottom of the project. If we continue, we can see that the user code begin PFP, the private function prototypes, and the user code end PFP. User code begin 0 and user code end 0. Those are the area where you set different functions or different prototypes or different settings just before you start the main. User code begin 1 and user code end 1. This is where you put your local variables and other settings just after the main starts. MC configuration has all the initialization of the HAL, of the system clock, GPIO init, and ADC init. User code begin 2 and user code end 2 is the area where you set different GPIOs and different settings and peripherals just before you start your while. User code begin 3 and user code end 3. Just after the user code begin 3, this is where all your code needs to be placed. And of course, your program will run between those brackets. After the main, there are all the STM32Cube system clock configurations. Those configurations, as I showed, are being called at the beginning of the private functions prototypes. So we have the system clock configuration, the ADC init that I just added, and the GPIO init. If I'll go back and I'll remove the ADC and I'll do project generate, I'll close it because my project is open. I'll click yes because the files has been changed, and I can see again that my ADC init is gone and I am left only with the GPIO init. If I go to the bottom, I have system clock configuration and GPIO init. Again, all the ADC has disappeared. So the STM32Cube is very sufficient and will remove any unnecessary code. If I want, I can do project, build target, and I can see I have 0 errors and 0 warnings. In the next video, I'll show how to use the HAL functions and how to use different peripherals like the ADC, GPIO, and other peripherals that are used on a daily basis. Thank you for watching. I hope you enjoyed it. Please subscribe to my YouTube channel so you can get more notifications when I upload more videos. Enjoy STM32.